So today we're going to continue on from what we were talking about yesterday with factoring with the difference of two squares and greatest common factor. But we'll try to give it a little bit of context. Why are we factoring in the first place? So what we're focusing on at the beginning of this class, or this course rather, is solving quadratics. And a quadratic is a expression or equation that usually looks something along the lines of this. Something like this, x squared plus x plus 1. There are different variations on what it can look like, but the defining thing is that it's a degree 2, meaning it has an exponent of 2 and nothing higher. So there's no x cubed, x to the fourth. 2 is the highest exponent that it has. So that's what makes it a quadratic. Quadratic is different than linear, which you've probably dealt with before, which is where your highest exponent is a 1. So something like this. If you don't have any exponent at all written, it's technically a 1. So linear is when you have a degree 1 polynomial, and quadratic is when you have degree 2. So solving something like this over on the linear side, much more simple than solving quadratic. Or it can be at least. So how are we going to solve quadratics? There are a number of different ways, and we're probably going to go over most, if not all of these. Just to name a few, we started talking about factoring already. You can use taking square roots. You can use something called completing the square. You can use quadratic formula. So there's a lot of stuff here. So when you're solving quadratics, you're going to have a lot of tools that you can use. Some cases you can only use certain methods and so on. So anyways, we're focusing now on solving by factoring. So talking yesterday about difference of two squares and factoring by greatest common factor, those are going to be things we can use to solve some quadratics. When we talk about solving something, that means we need an equal sign. And the ones we were dealing with yesterday, as I remember, I don't think we put any equal signs anywhere. Yeah, I don't think we did. So there wasn't anything to solve. Yesterday, we just had something, for example, like this, x squared minus 36, and we could factor by difference of two squares. So when we're talking about solving quadratics, we're going to have an equal sign, and we're going to want it to be equal to 0. So hopefully it's already given to us equaling 0. If not, we have to move things around to get it to equal 0. So if we were wanting to solve this, solve for x. Again, when we're solving for x, that means we're trying to find what value of x will make this equation true. So some number, if you square it and then subtract 36, it's going to give you 0. We have to figure out what number that is. So first, let's just focus on this left side and we're going to factor it. If we notice, we can do difference of two squares on this one. So we know it's going to be something squared minus something squared. And we know this is going to be x, and this is going to be 6. 6 times 6 is 36. And then from here, if you remember, this is going to become x plus 6, x minus 6. So here's the new piece where we're solving. So from here, you use a method called inspection. When you're solving for linear functions, like if you have x plus 5 equals 10, you say, okay, we're going to do minus 5 on both sides. You say x equals 5. You just used inverse operations to solve for x. But here, we're not going to do something like that. We're going to do something called inspection. And to use this method, it needs to equal 0, like we said. So notice we have two things being multiplied. When you're multiplying, if one of one of the numbers is 0, it makes anything equal 0. So let's just say that this parentheses was equal to 5. If this parentheses is equal to 0, the whole thing is going to be equal to 0, because 5 times 0 equals 0. So in this case, it doesn't matter what number is here. If this one's 0, everything's going to equal 0. Same thing if this one was a 5 or any number, doesn't matter. And this one over here, this parentheses was equal to 0. No matter what this number was, everything's going to be equal to 0. So this may seem confusing for the moment, but that's just to say, when we're solving by inspection, we want to find out how to make this parentheses equal 0, and then how to make this parentheses equal to 0. Because if we can make one of them 0, 0 times the other one, no matter what it is going to make everything equal to 0, which will help us, or which will be the solution to our equation. So x plus 6, x minus 6. If we take, let's take this second parentheses. What value would we have to plug in for x to make this whole parentheses equal 0? Take a second and think about it. That would have to be 6. If you put in a 6 for x, 6 minus 6 gives you 0. So you say x equals 6. And you'd plug in, when you plug in for x, you'd plug it into both parentheses. So you'd also plug in a 6 over here. 6 plus 6 would give you 12, but it doesn't matter what that one is, like we were saying earlier, because it's now getting multiplied times a 0. 12 times 0 is 0. So positive 6 is one of our answers. Now we have to come to this other parentheses and say what value of x is going to make this one equal to 0. This one's going to be negative 6. If you plug in negative 6 for x, negative 6 plus 6 would give you 0, and then your whole equation would equal 0, which we want. So here we got that x equals positive 6 and x equals negative 6. So we were able to just solve by inspection. Let's look at a couple more, just doing the inspection part. So we'll pretend we already factored and we wound up with something like, for example, this. Oops. So what would we get for x if we solve this one? So just take one of the parentheses, and we're asking what value of x is going to make this whole thing equal to 0. So we plug in some number, we add 2 to it, and we want to get 0. What's that number going to be? And it's going to be x equals negative 2. Negative 2 plus 2 would equal 0. Same thing, move on to the next parentheses, x minus 2. What value of x is going to make this equal 0? That's going to be positive 2. Positive 2 minus 2 equals 0. So we found our two answers, x equals negative 2, x equals 2. Let's look at one more together. Let's say we have x minus 7, x plus 5 equals 0. Actually, let's go ahead. Let's try this one as a practice problem. So let's pause the video. Go ahead and try this one out. You should get 2 values for x. All right, let's have a look. So first we're saying what value of x will make this parentheses equal to 0. That would be x equals positive 7. So it's basically just the opposite sign of whatever's there. Because if you do positive 7 for x, positive 7 minus 7 would give us 0. So positive 7 is one of our answers. And what would make this one equal to 0? that would be -5. If you plug in a -5 here for x, you do -5 plus 5, that becomes 0. So x equals 7, x equals -5. So that's solving by inspection. Now, the expressions we were factoring yesterday with greatest common factor method, I don't think we did any quadratics. So I think kind of the extent of what we were doing was something like, I think we did things like, so something like that. So number one that has two different variables. So that's not going to be a quadratic. I don't think it can be a quadratic if it has two variables. Well, anyways, the important thing is, or the thing that we'll focus on here at least, is that we don't have a 2 for our highest exponent. We don't have a 2 for the exponent at all. So we're going to be looking at ones that are just slightly different. Something like this. Let's say we have 15x squared times, oh no, sorry, plus, let's say 10x. Yeah, this is good. And let's make it an equation, set it equal to 0. So let's go ahead and solve this quadratic equation. It is in fact a quadratic equation. It has a 2 for the exponent on our variable. There's no higher variable or no higher exponent. So this is a quadratic. This one, if you notice, we couldn't factor it using the difference of two squares method for one reason, because it's not a difference, it's not subtraction. So here, it's going to turn out we can do greatest common factor. So remember what we said for greatest common factor, which is to start with the numbers. So 15, you can do 1 times 15, or 3 times 5. 10, you could do 1 times 10, or 2 times 5. What's the greatest number they have in common? 5. So when we're factoring this, you can take out a 5. But then also let's look at these x's. They both have an x. X squared, that means you have two x's being multiplied. So this is really 15 times x times x. This is 10 times x. And we're taking out the greatest common factor. Factor means thing being multiplied. They both have an x being multiplied, so they also have an x in common, which means we can take out not just a 5, but also an x. Then we're saying 5x times what gives us 15x squared. Start with the numbers. 5 times what number gives you 15? 3. 5x times 3 gives us 15x, but we want 15x squared. We only have one x. We need two x's be multiplied, which means we want to put another x over here, because remember, x times x is x squared. And that's just something you'll probably get very familiar with over time if you're not already. X times x is always x squared. So if you have an x, you need to get x squared, just multiply times an x. We drop down whatever sign is there, plus, and then 5x times what gives us 10x? That'd just be 2. Make sure we have our equals 0. If you start off with an equal sign, your equal sign should always be there, should never disappear. So we have 5x times 3x plus 2 equals 0. And for these ones, you also would solve these by inspection. But I think it's going to be a little, it's going to get us into too many different things if we start looking at that now. So we'll save that for later. So let's just do some more practice with factoring these quadratics using the GCF method. So let's say we have 3x squared plus 6x equals 0. Let's try this. So focus on the numbers first. 3 is just 1 times 3. 6 could be 1 times 6 or 2 times 3. The greatest number they have in common is a 3. So we can take a 3, put it on the outside. But we're leaving a little space here because if we notice, they also both have an x or multiple x's, it looks like. So let's figure out what they have. So 3x squared, that's really 1 times 3 times x. 6x is 2 times 3 times x. Oops, we put 2 multiplications in this. And we're taking out the greatest common factor. So we already took out the 3 because they both have a 3. They also both have 1 x in common. Careful, it's how many they have in common. Don't think this is 2 x's. They just have 1 x in common, so you're taking out 1 x. And then we're saying what's left over. So 3x times what gives us 3x squared? We'll focus on the number first. 3 times what number gives you 3? That'd be a 1. And then we need to get from x to x squared. Like we said earlier, you just multiply by another x. 3x times 1x. The 3 times the 1 gives you a 3. X times x gives you x squared. So there we have our 3x squared. And you also could have found that, again, by just looking at what's left over up here. So we took out the 3 and the x. That's our GCF. And you're left with a 1 and an x. 1x. Then dropped in the sign. Again, here we have plus. And then we're saying 3x times what gives us 6x? That's going to be 2. And again, you could just look up here for what was left over when you took the 3 and the x out. And don't forget our equal sign, like that. So let's go ahead and try practice. We'll squeeze it in so you can look at this one. This is practice number, I think it's 2, I might be wrong. So this one, let's go ahead and try, we'll say 8x squared minus 6x equals 0. So go ahead and let's pause the video and try this one out. 8x squared minus 6x equals 0. So let's have a look. Let's rewrite it over here so we have some more room. Focus on the numbers first. 8 you can get by doing 1 times 8 or 2 times 4. 6 you can get by doing 1 times 6 or 2 times 3. What's the greatest number they have in common? They have, looks like just 2. So we can take out a 2 and let's leave a little space to see if we can take out anything else. So 8x squared, that's 2 times 4 times x, because again, this is telling us we have 2 x's being multiplied. And over here, 6 is 2 times 3, and we just have 1x. So we already took out the 2 that they have in common, and they also have an x in common, just like before. So we can also take out an x. Then we're asking the same question, 2x times what is going to give us 8x squared? Focus on the numbers first. 2 times what number gives us 8? That'd be 4. And then we need to get from x to x squared, so multiply by another x. Again, you could look up here. You could see what we were left over with when we took out 2 and x was 4x. That's exactly what we put here. Then we have minus this time, so minus. And then we're asking 2x times what gives us a 6x. 2 times 3 gives us 6, so that's going to be a 3 right there. And again, you could look up here. The thing we had left over when we took out 2x was a 3. So there we go. We have our factored quadratic. So from here, let's go ahead and move on to classwork. Classwork number